So to study the control system first of all. So what is meant by control and what is meant by systems? So if you are observing that everything is going to be in doing some actions, every work is going to be there with some actions. So for that actions, some input we are giving, right? So with the reference of input, the system is going to be what? So what is the system? System is nothing but it is anything in this universe, we are calling it as a system. So for example, human body is a system, right? So it is a combination of different systems. Human body is a system, but it is the combination of multiple operations, multiple actions is going there inside our body, right? So how we are going to be controlling our body? So the perfect person is there, nothing but healthy person. We are calling it as a ideal one. So if any disease will comes to human being, then the human being is going to be react with a different way, right? So when he get the fever, then he feels some illness and the body temperature is going to be rise, right? So few people will get vomitings like that. Different actions we can observe compared to a perfect healthy human being, right? So that's why I'm calling a human being is a system, but it is a respond to natural as well as man-made works, man-made systems. So coming to in practically in electrical systems, we are using a lot of electrical equipments, right? So for example, lights, fans, motors, right? Computers, mobile phones, everything we are using. So those equipment we are calling it as a system. Those equipments we are calling it as a system, right? So we have to control all the systems to perform a accurate output, to get the accurate output. So now summer came, right? So when summer comes into the season, what will happen? We are going to be turning on the fans or coolers or ACs in the house. So to maintain the temperature of the house with the cool way, right? So the temperature must be less than 20 degrees Celsius or less than 25 degrees Celsius. To maintain the temperature, we are using the electrical apparatus, right? So we are going to be controlling the temperature of the room, right? So everywhere the control action is going to be taking place for our required way. So in this, we discuss units. Now I will give the small introduction about the all units over here. So first unit is going to be deal with the introduction about the control problem. So what are the problems will rise in the systems, how we are going to be controlling it, that we will going to be discussed in our first unit, as well as we are taking some practical examples. We are taking some practical examples, whether it is industrial or domestical or household appliances, all the things we are going to be taking some examples and checking how we are going to be controlling the parameters, right? So what are the problems is rise in the controlling action that we can going to be controlling, how we are going to be controlling, that we will take by taking some examples, and how we are going to be controlling that we are going to be representing in a mathematical way, right? So in mathematical way we are going to be representing it, and to achieve the control action, we are going to be taking some mathematical functions. So, for example, in case if anybody get fever, then what happen? If he is healthy person, then his body temperature is up to 95 to 96. 97 is the maximum for ideal case without fever consideration. So that is the ideal temperature, 96 and 97. When he get 98 degrees, 98 degree Fahrenheit, then what will happen? Then he feel some sickness and he will feel fever. So at that time we are going to be adding some medicine to that person to control the temperature in our body, right? In his body. So we are going to be controlling the temperature of that person body, right? So the fever is going to be reduced. So like that, we are going to be taking some examples. So nothing but what we are doing by taking the dosage of medicine, we are going to be controlling the temperature, right? So we are checking all these parameters in mathematical way only. So how many days we have to use that medicine? How many days we have to continue the uh, energy levels, maintaining the energy levels in human body, right? So coming to in physical systems like any motors. So how we are going controlling the speed? So for example, our ceiling fan. So ceiling fan is a system, and how we are going to be controlling the speed of the ceiling fan? By using the regulators, right? So by using the regulators. So what that regulator is going to be do? The flowing of current in that induction motor, that is nothing but fan, is going to be controlling, right? So due to that, the speed of the induction motor, that is nothing but fan, is going to be reduced or increased depending on the your position of the regulator, right? So how we are going to be taking? By reducing the amount of voltage and current, we are going to be taking that we can see in the mathematical way. According to Ohm's law, we are going to be taking consideration as V equal to IR. When you are varying the resistance, then flowing of current or else voltage across the motors or elements is going to be changed, right? So like that. So and now control hardware and their models. So what type of control equipments we have to take, how we are going to be designing it, right? So the model, right? So the models we have to take the consideration to get the higher accuracy in the controlling parameter to get desired output in a system, right? So have to take the different types of hardwares components and combining together to make the controller and giving their models to the system, then it is going to be controlling, right? So like that. Next topic is transfer function. So how it is responding? Transfer function is nothing but it is the ratio of Laplace transform of output to the Laplace transform of input with zero initial conditions. So with zero initial conditions, there is no predetermined value for that pre-stored value. Just when we are giving the supply, when we are giving the input, how the system is working, and when the system is working, what is the output it is giving, right? So that is the consideration to get the transfer function, right? So based on that output and input, that is nothing but your input and system output and system operation, we will get the transfer function, right? So that can be calculated for only linear time invariant system. So if in case if it is time variant system we are going to be taking consideration, so it will not give the proper linear output because it can change with the time. the system is going to be changed with the same input, right? The output may changes, right? So that's why. And next one, so types of systems we have to decide. So we will have the types of control systems and types of systems, and classification of systems will be there. So for example, if we are going to be taking classification of systems, so man-made control systems will be there, natural control systems will be there, man-made and natural control systems are also there. So every control system is going to be utilized to survive a human being with healthy and atmospheric conditions only, right? So in feedback control, that is nothing but in types of systems. So we are having two types, open loop and closed loop. So all the open loop and closed loop systems. So that we are going to be in our first unit. So for example, if we are taking controlling of fan or else controlling of tube light. So when you are going to be switching on the tube light, what will happen? The light will be gives the illumination. That is nothing but it will be turned on. So when you are going to be turn off the switch, then what will happen? The light will be turned off. So nothing but it is the on and off control. So it is an open loop system. So when you are required, you are going to be switching on it. When you are not required, you are going to be switching off it. So it is the open loop control action. If same thing for closed loop, if I am applying for same thing for closed loop, if any human body or a human being is there inside the room, then sensor will detect that human being and the light will be turned on automatically. The switch will be turned on automatically. So that is nothing but it is the when the person is leaving in the room, then the light will be turned off. So it is the closed loop action. So in presence of sensors, we are using the equipments, right? So if it is required, then it will be turned on. If it is not required, it will not. It will be turned off, right? So it is the closed loop system. So in detail, we will discuss while discussing the first unit by taking some examples also. Okay, and benefits of feedback. So when we are taking the sensors, that is nothing but feedbacks. So we can easily control the output for required one. So we will discuss the benefits of that. And we are representing these all the systems in block representation. So block diagram. So in previous studies we can discuss about, we already known about that pie charts, right? So pie charts are graphical charts are circular graphs, circular charts. So nothing but we are representing any function in the graphical way, right? So that way we are going to be representing here block diagram algebra. So here I will tell that simple example I am going to be taking. Our college, it is nothing but it is an engineering college. So engineering college. So it contains 5 branches, right? It contains 5 branches. So all these 5 branches are going to be dealing with different work, right? So civil, triple E, and mechanical, CSE, and mining, right? So all these 5 branches will be there. So civil will go for the building constructions and all the things, and electrical apparatus, right? Generation systems and transmission, distribution, and loads, and mechanical. So designing of machines and operation of machines, all the things by utilizing the electrical energy and mechanical energies also, right? So CSE, and that is nothing but developing the IoT systems and software based controls, all the things, and mining. So it is the complete mining operation. So different operations, different works is going to be learned in a single coverage, right? So representing the one Manthani. So that we are going to be representing in one block. So when we are visiting this college, what we learn? It contains the civil branch, it contains the electrical branch, it contains the mechanical and CSE and mining, like that. So if we are going for the civil, then it can contain the 4 year course, and first year, second year, third year, fourth year, like that. So in each year, we are going to be learn from the basic fundamentals. So in first year, we will learn about the basics and the utilizing of basics in the second year, and third year application oriented we are going to be representing, and fourth year we are going to be do the project work. So all the things we are going to be do in a 4 years of life in the single topic, right? So this total work is done by an human being, right? So to get an degree, so education, and you are going to be take the educational certificate to do the practical exposure outside in that stream, right? So like that we can take the representation in blocks, right? So we'll discuss about this block diagram in detail by taking the practical examples and taking the algebras of that. Okay. Next one, going to be second unit, that is going to be representing with the response. So in previous unit, what we are discussing, we are discussed about the input is there, output is there, right? And system is going to be responding. But when the time, within the time period, how the system is going to be responding by giving the input as some test signals. So we are having the standard test signals are sinusoidal waves and rectangular waves, right? So ramp wave, sphere wave. So these are the practical waves we can available in our laboratory. So when we are giving that input signals to any system, and it will give the some response that we can monitor in the CROs, right? So that we can observe in the CROs. Based on that output, we are representing the response of the system, right? So time response analysis of the standard test signals. So we are having the ramp, step, and sawtooth waveforms and sinusoidal waveforms, right? So, and the systems. So, what type of systems we can consider? We can consider the first order systems and second order systems, right? So, basically, the first and the second order systems are performing for the testing point of view. So, for that systems, we are taking the time response, and we are applying the initial and final value theorem to that system response. We can get the initial values and final values from the response of the systems, right? So coming into next one, design. How we can design the systems first of all. So in previous we have know that designing of system, right? So mathematical model and of the physical systems, right? And control hardware and their models we are going to be taking, right? So for that we have to design it for specific output. So if I want to maintain a room temperature as 20 degrees Celsius in every season. So in such a way, we have to take the some output, desired output. Based on that, we have to take the components and parameters we can combining together and making it as a system. So whether it is first order or second order, whatever it is, right? We have to take the system, and that system we are going to be give the input, then it is responding or not. It is maintaining the room temperature as 20 degrees or not. That we have to check it. Okay. So design specifications for second order systems based on the time response. So based on the time response, whether it is achieving that output or not. If it is not achieved, then we have to remodification of that system by changing the connections or by changing the components. All the things we have to redesigning it, and the system must be in the stable operation for every situations. Right? So that's why we are going to be finding about stability of that system. Okay. So based on the Ruth Harvey criteria, that is the method to find out the stability of the system. Okay. So the system is working stable or not. If it is not giving the response, if it is giving the response properly, then system is stable. If it is not giving the response as constant way, then it is going to be some disturbances will be there, right? So that is unstable system, right? So we can make it as a stable system by eliminating that errors, right? So to know the system is stable or not, that we can calculate it by using the Ruth Harvey criteria method in our second unit. And coming to the operational point of view, whether it is relative stability analysis. So in the operational point of view, system is performing while system is operating, then the output is completely violating, or else how much up range it can be stable. After that, it goes to violate. So that can be analyzed in the stability analysis by using the root locus technique. It is also one of the technique to find out the relative stability. Okay, so whether the system is stable or not, that is also going to be find out by using the root locus technique. And that construction we are going to be discussed in second unit. Sorry. And in the third unit, when we are giving the time signal, okay, those time signals are ramp signals and step signal. But when we are coming into the sinusoidal signal, it is the complex variable, right? So in that sinusoidal signal, we are having the frequency term. So when we are giving the input as a sinusoidal signal, then we are going to be take the response as output. That response we are calling it as a frequency response of the system, right? So that we are to take analysis and can interrelating with the time and frequency. So what is the difference between their time response and frequency response analysis? So how it is going to be daily, that we can check in the third unit. So to find out the stability of the system using the frequency domain, we are going to be using three methods, that is polar plots and boat plots and Nyquist stability criteria. Based on these three, we can calculate that the system is stable or not. So by using the Nyquist criterion, we can easily calculate the relative stability. But in time domain, we are using the root locus method in second unit. But in third unit, we are representing the frequency response. So Nyquist stability criteria we are using to find out the relative stability. And in third unit, we are representing with the single loop systems, and that is nothing but open loop systems and closed loop systems also. Okay. So in second unit also, open loop systems and closed loop systems, both we can consider to know the response of the system when time is a parameter. Okay. So coming into a fourth thing, if any system is having disturbances, we need to control it, right? To get the desired work. That is, we get the accurate output. So that errors we have to eliminate, right? We have to modify the system. But if the system is already designed, then the errors are producing. So if we are replacing the system continuously, then the economical point of view it is going to be very high. So the modifications by varying some parameters in that system, then we will get the output accurately, right? So that's why we are using controllers. We are using controllers. So for example, our room is having a air pressure when it is going to be rotating cooler, when you are operating cooler. So if you are open a window by using the controlling method, if you are using an open window with a little bit gap, then what will happen? The flowing of air from the room to outside will there through the window, right? So if you are standing outside of the window in that gap, what will happen? You can feel it is a very cool air is coming from the room, because the room is going to be maintained very low temperature and outside of the room is very high temperature. So nothing but the of wind controlling of wind direction as well as opening of a window position. So that is designed by ourselves, right? And in this controller, is there any changes in the stability operation or steady state accuracy and transient accuracy? So steady state operation and transient operations will be there in the response of the system, right? So is there any violations will be there when we are introducing the controllers in the system? That we have to check. And as well as we have to remove the disturbances in the system. We have to remove the disturbances in the system, and the sensitivity of the system, whether it is violating or not, that is also going to be checking and in the control system. Checking in the control system, right? So in this, we are going to be designing the controller. We have to go for the root locus method only. And if we are going for the in frequency domain method, in frequency response, then we will go for the compensators. We will go for the compensator. So in time response, we will go for the controllers, that is proportional controller, integral controller and derivative controllers. But if we are dealing with the frequency response of the system, then we are going to be taking a lead lag compensation in designing. So to control the output parameter. And generally we know that analog and digital implementation of controllers, right? So in olden days, the analog controllers will be there. Nowadays we are using the digital controllers, right? So like that. And unit 5 is representing with the state space representation. That is nothing but all in our fourth unit, up to fourth unit, we are going to be taking only single input and we are checking the output parameters and whether the system is stable or not, all these things. But coming into the fifth unit, we are going to be taking multiple inputs and multiple outputs. Multiple inputs and multiple outputs. Okay? So in that multiple inputs and multiple outputs, when one input is going to be changed, all the outputs are going to be changed. That we are going to be analyzed by using the state space representation. So in that we are going to we have to know about that state and what is state variable, how the state variable we have to take, and how we can form the state space model, right? So in simplification of that response, we are going to be taking diagonalization of matrix. So diagonalization of matrix we are going to be taking for analyzing the response of the systems and state equations. And in diagonalization, we will go for the different new parameter changes by using the eigenvalues and eigenvectors. So that we are going to be checking in the fifth unit. And the system is controllable or not, and only it is observable or not. That is also going to be discussed in our fifth unit. Okay, so all these things are linear time invariant systems, right? But in fifth unit, we are going to be taking for linear discrete time systems. So discrete time systems, we are going to be consideration in the system that is nothing but non-linear systems we are going to be taking. And in this state space analysis, we can easily calculate that the response of the systems, linear time discrete systems, and response we can easily calculate. So all these 5 units are going to be taking consideration for controlling of any systems only. So for this, we have to going to take the textbooks are Control Systems, the Principles and Designing by M. Gopal, and Automatic Control Systems by B.C. Cow, and reference books, that is the standard books, reference books are Modern Control Engineering by Ogata and Control System Engineering by I.J. Nagarath and M. Gopal. So these are the textbooks and reference books. Another book is also there, that is the to understand easily the concept Nagurkani. So Control Systems by Nagurkani is also there. So, and while we are going to be taking the course, what we are going to be taking, learning from that, right? So the objective of this course is to know the system and system representation and transfer function representation and state space representation, and also analyze the response of the system. So we can easily understand that by using this course, and we can easily calculate the performance characteristics in time domain system and the improving in the time domain system also. The performance is also going to be improved in time domain system also. We can check it. And also in frequency domain also same thing, right? So, and the designing of controllers and compensators also we can take for improving the system performance. So these are the objectives of this course, and the course outcomes are, so what we are learned from this one, so nothing but we can easily understanding the modeling and its operation and stability of the system and designing of the controllers. All these things we can easily do when we are learn this subject. Okay, so what are the overview? What is the overview of the course? So the complete overview I am going to be giving in the representation over here. So first one is the aim of this course is to know about system and types of systems and classification of systems and controlling parameters, control systems and different types of control systems, right? So all these things we can learn it, and always designing parameters, designing of systems, designing of controllers and designing of compensators. We can easily do the after completion of this course. And we can easily analyze the system modeling by mathematical way, and we can easily analyze the performance characteristics of system by using the different methods. And we know the standard signals, how we are going to be generating that standard signal, how it is going to be giving the response when the system is giving to when the signal is given to the any system, that we can easily learn it. That is nothing but performance of the system with input signals. So that is time response and frequency response. And the stability we can easily analyze when a system is stable or not. That we can easily tell that by using the root locus, Bode plot and Nyquist plot in the time and as well as frequency response. And the correction of errors that can be done by using the controllers and compensators. That controllers and compensator we can easily design, right? We can easily design. And state space modeling for multiple input and multiple output operations of the systems. So I will show some examples over here. Okay, so this is the example of control system. If you are observing that the conveyor belt is moving step by step, right? So when it is moving in the first one, what will happen? The water bottle comes down, right? And when it comes to second step, the water bottle is filled with the liquid, right? And when it comes for the third step, it is going to be close the cap of that bottle, and as well as fourth step, it is going to be taking out to packing, right? It is going to be take a system to make the water in a bottle, right? So it is doing the multiple tasks. So the complete system is, we are calling it as a manufacturing of water bottles and giving the water bottles with the filling of water with a seal, right? So all these things operated in a system. So that can be controlled. If I am going to turn off the system, then what will happen? The production of that is going to be turned off, right? So if I turn off the middle operation, that is nothing but filling of water. So what will happen? So in the third step is also the water is not available, right? So everything we have to looking at the sensors and manual operations and automatic operations, right? So another one. So for example, crossing of road, right? So when green signal comes, then automatically what will happen? So when green signal comes, then the road will goes, the vehicles will goes like this, right? So the remaining three ways, it is having red signal, right? So nothing but it is representing with the red mark. So that's why the vehicles is not allowing to move. So it is going to be controlling the traffic. So to avoid the accidents in the traffic, right? So for example, I already told you that human being is a system, right? So I'm going to be take the one of the system, that is heart function. So the blood circulation through from the heart to our body and from body to heart. So if you are seeing that from body to heart, the blood is coming and that can be combined to go and it will be goes to lung, right? So like that, the heart is going to be taking the function, right? So if any of the function is going to be get disturbances, what will happen? Human being get heart attack or else chest pain, heart pain, right? So like that. So he will get sick. So he will going to be take the controlling of all the flowing of blood in the water with the proper velocity, right? So that is nothing but if the blood pressure is very high, that is nothing but from the body to heart, the blood will flow with the higher speed, and the function of heart rate will be increases. So it may puncture the valves of the heart, right? So it is also one type of control system in human being. So it is going to be there in natural way, right? So another example I am going to be showing here, general control loop diagram. So here I am going to be take the controller. So this is the controller I'm going to be taking. So this is the set point. So what is the desired value I'm going to be set from this one, and that can be goes to controller, and from controller to control element. So what is the control element that is going to be controlling here, and that can be going to be give the process, that is nothing but it is the system. So the system is going to be give output. If in case any disturbance will be there, the output will be changed, right? So that output again we are going to be take further correction if we are not give the desired output here. So if we are not get the desired output, then the feedback we are going to take, that is nothing but using the sensor transmitters. So that can be going to be give the error detector. It can compare it with the set point. So if in any violations will be there, then again the control signal will be, error signal will be produced to controller. So this controller will modify the control parameter, and it will give to the system. Then the required desired value it will be get. So if you are seeing that the arrow direction, so it will be flow like this. So when the disturbance signal will be raised into the system, then automatically the feedback will be turned on. So from the next class, we'll start the next, that is nothing but first unit. We'll start the first unit, and we'll learn one by one, step by step. So first of all, we have to know how the what is system, how the system will be give the designing, right? So what are the parameters will be there in the system and control system, and types of systems and types of control systems, and classification of systems and classification of control systems. All the things we will discuss in the next class. So wait a minute, I will take the attendance right now. After that you can rejoin. I will show some practical examples, what we are doing, what we are controlling in the outside area, that we are every day we are seeing it. So that I will show a video for you. So don't leave the meeting. I'm going to be taking the attendance right now.